So let's try to practice with some of the new information that we've learned. The first thing we always do before we start a problem is put the given information on the diagram. In this particular problem, we have circle X with segments AD and segment BE being diameters. The measure of angle EXD is 65, and the measure of arc CD is 41. You'll then see that we're asked to find several measures of arcs and angles. But I find that it's much easier to just start marking up the diagram with everything I know, based on all the information I know from the past, in addition to all the new information that we've learned. Sometimes it's not so easy to just go and answer the questions in order because you may not be looking at the diagram in the same way. So what I tend to do is just start looking at the diagram, looking for vertical angles and central angles and inscribed angles and angles who have their vertex on the circle and angles who have their vertex inside the circle and the sum of the measures of the angles of triangles and things like that until I mark up as much as I possibly can. And then I go back and start answering the questions. And if there's any left over after that, then I go back and answer those as well. So right away, I know that if the measure of angle EXD is 65, then the measure of angle AXB is also 65, because those are vertical angles. I also know that arc ED, the measure of arc ED, will be 65 degrees, because the central angle that intercepts that arc is angle EXD, and the measure of a central angle and its arc are the same. Now I know that the measure of arc AB is also 65 degrees because its central angle is angle AXB, and the measure of a central angle and its arc are the same. So they're both 65 degrees. If I go back to linear pairs, then I know that angle AXB and angle AXE must equal 180 degrees. So if I take 180 degrees and subtract 65, then I know that the measure of angle AXE is 115 degrees. And again, because angle AXE and angle BXD are vertical angles, angle BXD is also 115 degrees. And again, based off the fact that angle AXE is a central angle and it intercepts arc AE is 115 degrees. And angle BXD is a central angle and it intercepts arc BD, so the measure of arc BD is also 115 degrees. If I know that arc BD has a measure of 115 degrees and arc CD has a measure of 41 degrees, then if I subtract 41 from 115, I know the measure of arc BC is 74 degrees. Now I'm going to start looking for angles that have their vertex on the circle, or inscribed angles, that I know have a measure that is half the intercepted arc. So if I look at angle AEB, that angle intercepts arc AB, which is 65 degrees. And if an inscribed angle is half the measure of its intercepted arc, then the measure of angle AEB will be 32.5. Likewise, angle ADB also intercepts arc AB, so it will also be half of 65, or 32.5. Angle EAD also intercepts an arc of 65 degrees, and an inscribed angle is half the measure of its intercepted arc. So again, 32.5 degrees. And angle EBD also intercepts arc ED, which is 65 degrees. So that angle is also 32.5 degrees. We have one more inscribed angle, angle BEC, that intercepts arc BC, which is 74 degrees. And because it's an inscribed angle, it's half the measure of its intercepted arc. So 74 divided by 2 is 37 degrees. At this point, I'm going to stop and start trying to answer the questions below and see how far I get and see if I'm missing any information. So the measure of arc ED, we have that. It's 65 degrees. The measure of angle BXD, we have that, 115 degrees. The measure of angle AXE, also 115 degrees. The measure of arc AE, also 115 degrees. The measure of angle AXB is 65 degrees. The measure of arc AB is also 65 degrees. The measure of angle AEB is 32.5 degrees. The measure of angle BDA is 32.5 degrees. The measure of arc ACE. Okay, well that's a major arc. Means we start at A, go through C, and end at E. If I add all of those pieces together, I'll get the measure of arc ACE. So starting at A, I have 65. I keep going, I add 74. I keep going, I add 41. I keep going, I add 65. And then I stop at E and add those together. When I add all of those together, the measure of arc ACE is 245 degrees. The measure of arc BC we have is 74 degrees. The measure of angle AEC, again, made up of angle AEB and BEC, so we'll have to add those two together, which is 32.5 plus 37, and together that equals 69.5 degrees. And the measure of arc BEC. So again, a major arc that starts at B, goes through E, and ends at C. And if we notice, that's the entire circle except for arc BC. So we can also do the entire circle, which is 360 degrees, minus arc BC, which is 74, and the entire arc BEC will be 286 degrees. Let's try one more with the information we've learned so far. Now we have circle Q, and arc AD is equal to 80. Arc CD is equal to 115. And the measure of angle 3 is equal to 70 degrees. So if we start trying to answer the questions, the measure of angle 2. Well, the measure of angle 2 and the measure of angle 3 are a linear pair. So if I take 70 degrees away from 180, the measure of angle 2 is 110 degrees. And it may help me later on, so I'm just going to look at the vertical angles here real quick and fill in the rest of the angles around that intersection point. We lost our arc symbol, but we're looking for the measure of arc BC. When I follow that back, I find that that arc is intercepted by two chords that intersect inside the circle, but not at the center. So what I have to remember is that the measure of an angle created by two chords that intersect inside a circle, but not at the center, is half the sum of the two intercepted arcs. So 70 is equal to x plus 80 divided by 2, which just sets me up with a little equation that I have to solve. So when I multiply both sides by 2, I have 140 equals x plus 80, and when I subtract 80 from both sides, I'll find that the measure of arc BC equals 60 degrees. If I want to find the measure of angle 4, I need to follow its sides out and see that it intercepts the arc from B through C all the way to D. That arc is 115 degrees plus 60 degrees, which is 175 degrees. And then remember that the measure of an angle whose vertex is on the circle is half its intercepted arc. So that will be half of 175 degrees, which is 87.5 degrees. The last thing I need to find is the measure of arc AB. I have all the rest of the pieces of the circle, so I can just subtract off the other pieces from 360. So 360 minus 60 minus 115 minus 80 will give me the measure of arc AB, which is 105 degrees.